Hello, my AP Statistics students. Mr. Luya again here, and I wanted to go over yet another FRQ from an old AP exam where you have to identify the inference method and perform the four-step process procedure. So let's go ahead and figure out what method we're going to use for this problem. It says high cholesterol levels in people can be reduced by exercise, diet, and medication. 20 middle-aged males with cholesterol readings between 220 and 240 milligrams per deciliter of blood were randomly selected from the population of such male patients at a large local hospital. 10 of the 20 males were randomly assigned to Group A, advised on appropriate exercise and diet, and also received a placebo. The other 10 males were assigned to Group B, received the same advice on appropriate exercise and diet, but received a drug intended to reduce cholesterol instead of a placebo. After 3 months, post-treatment cholesterol readings were taken for all of the 20 males and compared to pre-treatment cholesterol readings. The tables below give the reduction in cholesterol level pre-treatment reading minus post-treatment reading for each male in the study. So here you have Group A. This is the reduction readings for all of them. Here's Group B, the ones who took the drug. There's the reduction readings for all of them. So a big battle that I've had with my students in the past is they never know whether or not to do a paired t-test, because I mean we have like two different groups here, to do a paired t-test or to do a two-sample t-test. If you look at this problem, it's not like they're comparing these pairs of people, this pair of people, that pair of people. Like, you know, if you remember from the 2014 exam, they compared like every pair of male and female who purchased the same car. With this one, they just kind of they're comparing like entire groups with each other. We have an entire group of people where they take the average reading from all of them and then compare. And then we have this, an entire group of people here got a bunch of readings for them and took the average of that group. This to me is very indicative that we're going to be doing a two-sample. And then let's see, it's two samples here. And I mean, it's kind of in the problem, but since we're dealing with quantitative data, it's a two-sample T. And let's see, is it an interval or is it a test? Do the data provide convincing evidence? That's the language that they always use for tests. Okay. Usually if you ever see the word estimate, or if they give you a confidence level, that usually means that you're doing a confidence interval. So just a little tip for future problems when you read them. Okay, so let's go look at this. So we know we're doing a two-sample t-test, so we're now going to set up hypotheses. Do the data provide convincing evidence at the alpha equals 0.01 level that the cholesterol drug is effective in producing a reduction in mean cholesterol level beyond that produced by exercise and diet? So let's go ahead and see here. So when I set up my hypothesis, I'm going to have, let's see, mu A is equal to mu B, because I mean we're looking at Group A and Group B, so I'll just use A and B for that. Mu A and mu B. So the mean reduction for placebo is the same as the mean reduction in cholesterol level for Group B. Now for our alternative, this is where a lot of kids get tripped up on this one. If we want to compare mu A versus mu B, well, we want to know, is the drug more effective in producing a reduction? So in other words, we want to know, will this mean in Group B, the ones who are using the drug, will this mean be lower, right? No, actually higher. I'm sorry. Because the mean represents the reduction. So we want a higher reduction, or we want to see if it's more effective, we would have a higher reduction in Group B than we would in Group A, right? So that means that we want to make sure, or we want to test to see if Group B will be bigger than Group A, or that Group A is lower than Group B. I feel like I jumbled my words there a lot, and I even made a small mistake. So if that doesn't make sense, I would rewind and hear it again. But so yeah, that's a part that I can see a lot of students missing, and ultimately will give you the wrong answer at the end. So let's go ahead and define this, because who's going to read this and know what mu A and mu B is? We got to define it for them. Where we're going to say mu A is the true mean, let me shorthand cholesterol reduction for patients in the placebo treatment group. everyone's going to have their own way of phrasing this. This is how I want to phrase it. Is a true mean cholesterol reduction. I mean, as long as you have this part, and it's pretty clear what group they're in, then you're pretty much good to go. And treatment group, and mu B is equal to the true mean cholesterol reduction for patients. Let's just say in the cholesterol drug treatment group. Okay, we're using an alpha of 0.01. We're used to seeing 0.05, but this one's different. So alpha is 0.01. Okay, perfect. So we got our state, we define our hypotheses. I mean, you'll see, are you seeing a pattern here? It's the same thing every time. That's why that's why these problems end up being easy, even though you guys are miserable doing the problems during class. So now we're gonna go ahead and do our inference method. Okay, our inference method is, we already said, it was a 2-sample t-test, and ultimately we're trying to figure out the difference between the two. So I'm gonna say for mu A minus mu B. Okay, random. Is there any element of randomness in here, whether it was a random sample or random treatment assignment? Let's see, does it say that? No, we're randomly assigned to group A, and I'm assuming the same for group B. So I'm just going to go ahead and just say that the patients were randomly assigned to treatments. So patients randomly assigned to group A or B. Okay, as long as you acknowledge it, you're good to go. Independent. Now they did say that they got a sample of the patients. Let me see. Yeah, 20 middle-aged males with cholesterol randomly selected from the population. So our population of interest here is all male patients in the hospital, because that's what they said, from the population of such male patients at a large hospital. So all male patients, let's say like these, in the hospital. It's not all the male patients. They said of such male patients in the hospital. Is that greater than 10 times that sample of 20? Yeah, I'm just going to go ahead and assume that. I've even seen students in previous AP exams just say assume independence. And I mean, and they've gotten full credit for it. So I'm going to be err on the safe side and have us do it like this. It doesn't take that long anyways. So is this normal? Well, since n is equal to 10 for both, right, for both groups, right, because we don't have 30 in each one, and because we're dealing with mean, we either try to look at see if it meets the central limit theorem, or if we have to check for normality in the curve or symmetry in the curve, or not heavy skewness or outliers. That was very poorly worded, but let's see. Let's go ahead and draw our box plots. So stat edit. Let's make a box plot for each one. Oh, that's what the list was. So I already had the list for list 2. I'll just quickly do it for list 1. So 19, 8, 4, 12, 8, 17, 7, 24, 1. Hopefully I didn't mistype any of that. So let's see. Turn the plot on. We'll do the box plot that shows the outliers. We'll do it for list 1. Zoom stat. Oh, and I have some calculus in there. Let me turn that off. Oh, come on. Turn that off. Graph. There we go. And then I'm also going to turn on my other box plot just so that I can kind of compare them side by side. So I have on, list 2. I'll do that in red, I guess. Graph. Perfect. Oh, zoom. Zoom stat. Perfect. So now I'm just going to go ahead and do draw the box plot for them. So I have something that kind of looks like this. Maybe it's a little bit longer there. Voila. And this one kind of looks more like this. All right, and just to be safe, I'm going to go ahead and just give them little values. So 1, 4, 8, 17, 24, and then down here we have 4, 10, 18.5, 22, and 30. So there is no heavy skewness or outliers in either distribution. All right, so with that, we're good to go. All right, I should probably label this as group A and group B. There we go. All right, and then finally, we got to do our do calculation. So it's going to be using 2-samp t-test from the calculator. All right, so let me go ahead and do my test. So 2-samp t-test for list 1, list 2, frequency. Oh, we said that list 1 was less than list 2, so let's make sure we specify that. Pooled, no, calculate. There we go. So we got t is equal to negative 1.62. I think 2 decimal places is fine. Negative 1.62, and p is equal to, I'll do 3 decimal places for that, 0.062. Okay. All right. Let's keep going. So based off of that, our p-value, since p is equal to 0.062, and is that greater than alpha? Yep. If that's greater than alpha 0.01, this is a case where we fail. Since we fail to reject HO. So if we fail to reject this, then that means that there is not enough evidence for HA. So we got to say our language. So there is not convincing evidence that, and now let's just copy and paste. See, there's always that word "that" right there. So let's just kind of copy that next part. That the cholesterol drug is effective in producing a reduction in mean cholesterol level beyond that produced by exercise and diet. Let's just say it. So that's the cholesterol drug is effective in producing a reduction in mean cholesterol level. It's nice that you get 1 full point for pretty much just copying the problem. What is this, kindergarten? Level beyond that produced by exercise and diet. Perfect. All right, so there's the full 4-step process. There is the full credit for this question on the AP exam. So hopefully that was very straightforward. Hopefully this clears any questions you have or any confusions you may have on whether this is a 2-sample t-test or a paired t-test. And that's about it. Very, very easy way or easy question to get full credit on the AP exam. So again, if you have any questions, feel free to ask me, and I'll see you guys in the next video. Take care.